Now, let's proceed to Lesson 6, Free Fall. Siguro lahat naman tayo aware na there is gravity. And gravity causes objects to fall downward. So, in the absence of air resistance, it is found that all bodies at the same location above the Earth fall vertically with the same acceleration. So, furthermore, if the distance of the fall is small compared to the radius of the Earth, the acceleration remains essentially constant throughout the descent. This idealized motion, in which air resistance is neglected and acceleration is nearly constant, it is known as free fall. So, since the acceleration is constant in free fall, the equations of kinematics can be used. So, the acceleration due to gravity is denoted by the symbol G, and it is always directed downward toward the center of the Earth. So, dito daw sa Earth's surface, the equivalent or the value of the acceleration due to gravity is 9.81 meter per second squared in the SI system, or 32.2 feet per second squared in the British Engineering System of Units. So, unless circumstances warrant otherwise, we will use either of these values for G in subsequent calculations. In reality, however, G decreases with increasing altitude and varies slightly with altitude. So, since naman yung problems natin nagpo-focus sa sobrang liliit na displacement as compared dun sa radius ng Earth, so it is safe to assume that the value of acceleration due to gravity is constant. Now let's try to solve example problem 6.1. A stone is dropped from rest to the top of a building as the figure indicates. So, kunwari ito yung building. After 3 seconds of free fall, what is the displacement y of the stone? So, first, again, let us write down the given. Given. The initial velocity is equal to, of course, 0 meters per second since it started from rest. So, the time t is equal to 3 seconds. Next, we have so, of course, we have the acceleration due to gravity, which is equal to 9.81 meters per second squared. So, this is negative since it is directed downwards. So, huwag niyong kakalimutan yan. Required the displacement. So, for the solution, we will use the motion equations for constant acceleration. So, let us try to see kung anong equation yung pwede nating gamitin, since we have the initial velocity, the time t, and the acceleration due to gravity. And we are asked to find the displacement. So we can use this one. So the displacement, which is the unknown, the inertial, which is equal to 0, the time t, and the acceleration. So we can now write x minus x sub o is equal to initial velocity times time plus 1/2, so this is plus 1/2 at squared. So again, direct substitution lang. And this is equal to 0 meters per second times 3 seconds, cancel, plus 1/2 times negative 9.81 meters per second squared. And this is equal to 9 seconds squared. So this is equal to 0. And the acceleration, so and now the displacement is equal to 44.145 meters negative. So the negative sign indicates that the displacement is downward. So yan lang yung ibig sabihin niya. So commonly kasi ang ginagamit na sign convention is the upward and to the right, that is positive, and downward and to the left, that is negative. So next problem, we have a follow-up question. So example 6.2. After 3 seconds of free fall, what is the velocity v of the stone in the previous problem? We can simply use that the final velocity is equal to the initial plus the acceleration times time. So the final velocity v is equal to 0 meters per second plus negative 9.81 meters per second squared times the time t, which is 3 seconds. So 9 point. This is equal to 29.43 meters per second squared. Yan. Oh, again, negative. So, the negative sign indicates that the direction is downward. Let us now try to solve example problem 6.3. A football game customarily begins with a coin toss to determine who kicks off. The referee tosses the coin up with an initial speed of 5 meters per second. In the absence of air resistance, how high does the coin go above its point of release? Given initial velocity is equal to 5 meters per second. Next, the acceleration due to gravity, negative 9.81 meters per second squared. So, notice that at this point, at the initial position, the velocity or the initial velocity is 5 meters per second. And after reaching a maximum height y, the velocity is now equal to 0 meters per second. So, how come? Yung acceleration natin due to gravity, that is directed downward. So, yung velocity naman natin is pataas siya. Kaya, magkaiba yung direction ni velocity at ni acceleration. Kaya, ang mangyayari ay deceleration. So, kapag nagde-decelerate siya, makakaabot siya sa point na 0 na yung kanyang velocity. At kapag 0 na yung kanyang velocity, yun na yung maximum height niya. Meron tayong final velocity v, which is equal to 0 meters per second. So, ang pinapahanap ay the displacement y or the maximum height. So, we can use v squared is equal to v sub o squared plus 2 times acceleration times the displacement. So, direct substitution na since meron tayo nito, meron nito. The final velocity, 0 meters per second squared. The initial, 5 meters per second squared plus 2 times negative 9.81 meters per second squared times the displacement na sulat na lang natin na y. So, negative 25 meters squared per second squared is equal to 19.62 meters per second squared times y. So, negative ulit. Y is equal to 1.27 meters. So, yung nakuha nating displacement is positive. Ibig sabihin, pataas yung ating displacement. So, meron tayong additional problem 6.4. So, in the previous problem, what is the total time the coin is in the air before returning to its release point? So, we can denote the total time t as the capital letter T. So, meron tayong dalawang time na makukuha. Yung time niya pataas at yung time niya pababa. So, yung time niya, pataas, denote na lang natin T up. At yung time niya para makababa is T downward. Down. So, kailangan natin tong kunin para mahanap natin yung total time. So, we can use for T up, we have the final velocity is equal to V sub O plus AT. And this is 0. Di ba kapag pataas siya, kapag pataas ang final velocity niya is 0. 0 meters per second. At ang initial naman niya is 5 meters per second. Plus the negative 9.81 meters per second squared times time t. Yan. So, time up 5 divided by 9. So, 0.5097 seconds. So, actually, ganito yung sagot niya. So, pwede kayong mag-shift store sa calculator. Kung marunong kayong gumamit ng ganong function para mas accurate yung sagot nyo. So, for the time to return to its release point or yung time niya sa pagbaba, pwede nating gamitin yung nakuha nating displacement kanina, which is equal to 1.27 meters. So, we can use the formula x minus x sub o, or the displacement, is equal to the initial velocity times time plus 1/2 a t squared. So, yung ibang formula kasi is kailangan nyo ng final velocity. So, ito na lang yung gamitin natin para pinaka-convenient siya. So, this is also equal to y. Kasi, kung ano yung itinaas niya, yun din yung ibababa niya para masabi nyong nakabalik siya dun sa point of release. So, this is equal to 1.27 meters. And then, the initial velocity, since ito yung starting point natin, this is equal to 0. Times time t plus 1/2. So, since this is downward pala, this is negative. So, 1/2 times negative 9.81 meters per second squared. Lagyan na lang natin ng unit. Negative 9.81 meters per second squared times the time t na hinahanap natin. So, This is 0. Negative, so, solve na natin directly. So, t squared is equal to negative 1.27 all over 2 times negative 9.81. So, this is equal to 0.0647 second squared. Naka-square pa siya. So, kailangan natin tong square root. So, t is equal to square times 0.2544 seconds. So, ang pinapahanap sa atin ay yung total time na nasa air. So, again, we have to add these two. Yung time para ma-reach yung maximum point at yung time para makabalik dun sa release point galing dun sa maximum point. So, t is equal to 0.5097 seconds plus 0.2544 seconds. So, 0.5097 plus this is equal to 0.7641 seconds. So, that's all for this week.